This is the first time in my life that I'm going to speak in English for such a brief period of time. So if I make mistakes,
You see, sir, I can talk English, I can walk English, I can laugh English because English is a very funny language.
yeah, that never gets old. Okay, so this should be the last video of this series, but if I find something interesting, I'll make sure to add it in this project. In this tutorial, we're gonna find a suitable magnitude for a particular angle, which is just enough to hit the target. So if I have some angle, let's say I have angle 70, so there must be a magnitude, or there may be a magnitude that can still take our projectile to the target, in which case 9.5 seems to be the one. So for every angle there may or may not be a magnitude, but if there is, we're gonna find it. And we will also cover the other case, which is, let's say I have magnitude of 10, then there may or may not exist an angle which is just enough so that our projectile can reach the target. In this case it can be this angle or it can be this angle, so there are two basically. So we will create those functions in this video, so let's start as quick as we can. But first let me show you this. This is a Wikipedia page of projectile motion, and if you want to know more about the equations that I'm about to use in this project, this will be a very good page to start from. So we have some derivations and very good explanation of those equations, but in this video I'm gonna use those functions. I won't explain them, otherwise this video will become more of a math and physics video instead of Unity. So we're gonna use this equation, which will calculate the magnitude for the theta at which we are launching, and this one, angle of reach. So angle theta required to hit coordinate x and y, so we're gonna use this one. As we saw, at a given magnitude there were two angles that were hitting the target, so this plus and minus gonna give us both those angles. So let's implement them, and let's start by our beautiful script that we have created. Okay, let's start by taking a boolean which will trigger the calculation. So suitable magnitude and angle. Okay, and let's add them here because this is the place where we detect the change in magnitude and angle. So if this boolean is true, we're gonna call our function, otherwise we will just do what we used to do. Yeah, this looks right. Okay, then again we will do this. We will call our function if this is on, and if not, we're gonna keep doing what we used to do. Okay, let's call the function, and now we want a function that will return this new magnitude. So magnitude to reach x, y in gravity at angle. So let's create the definition of this function. So we will provide x, y, gravity, and that angle. So let's assume this is the result, which is 0 for now, and we will return the result in the end. And let's take a look at the equation. X square g upon x sine 2 theta minus y cos square theta. Okay, So before taking the square root of this inner equation, I'm gonna check if the result is negative or positive. Why, you ask? It is because if this is a negative number, we cannot take its square root because it is an imaginary number. So if inner is less than 0, we're gonna return none. Otherwise, I'm gonna so let's check if this works and if it doesn't, and let's pass the values. So our x will be the distance we want to cover in x direction, which is target.position.x we want to reach, minus transform.position.x, the distance we have already covered from the origin, of course. And same thing goes for y, and y. Gravity, so g is equals acceleration dot y, but we're gonna use a negative value. So we're gonna pass x, y, the gravity, and the angle for which we are calculating all this stuff. In case if the calculation of magnitude was not possible, the function will return a none, and we're gonna check if is none. If it is, we will reverse the change that we have made in our editor, and if not, we're gonna keep the change. And we will change the magnitude to this new value that we have calculated. And also we will calculate the velocity with this new angle and magnitude. So that should be it. If you have an angle of 45 degree, the suitable magnitude to hit the target will be 8.08. So as we change this, we can see that the magnitude is changing as well. So let's say for angle 70, the magnitude we need to hit the target is 9.49. Okay, so this seems to be working pretty fine. I like it. And let's do the same for the magnitude. So we will need the same thing for our magnitude, which is x, y, g, and new angle. And also we want a new function. So the function will return angle to reach x, y in gravity at magnitude, and we will provide the launch magnitude. And let's now implement this function. So here we are, a public float, the function name, and the function will take x, y, gravity, and magnitude. Okay, and let's look at the equation. The angle will be the arctan of v square plus or minus under root of v to raise to the power 4 minus gravity into gx square plus 2yv square upon gx. Wow, this is beautiful. So let's take it one by one. So float inner of square root. And now we have two sides of this equation, which is a positive side and a negative side, which I will tell you in a bit. But let's go with the positive side for now. Inner of A10 is equals to magnitude into magnitude, and we're gonna go with plus positive side of this equation, and we want a square root of the inner side of the inner side we have calculated for the square root, and this whole equation will be divided by gravity times x. Okay, and now we will calculate the arctan or tan inverse, if you want to say that. So our result will be equal to mathf A10 of this value right here, and we will return this result. The result of the A10 will be in radian, and we want our result to be in degrees, so we're gonna change it to radian to degree, and let's set up the rest. Here's the new angle we have calculated, and if the calculation was not successful, we will reverse the change. So launch magnitude will be the old value, and if that is not the case, we will happily change it to the new value, and we will change the launch angle to the value that we have calculated, and also we're gonna change the velocity accordingly, how it goes. And now if we are increasing the angle magnitude, we are changing the angle accordingly. So at the magnitude of 12, we can hit our target if we launch it at the 77.44 degree angle. Okay, now how about that negative case? Let's say I have the magnitude of 20, so the angle we should launch is 85.7, but how about if my magnitude is so high, I can also launch it at this angle. So where is this answer? That's the answer we will get if we use negative side of this equation. So let's add a boolean here, prefer a small angle, which is false by default. Okay, so now if we want to prefer a smaller angle, we will calculate the result using the negative side of this equation, and if not, we're gonna use the positive side of this equation, and let's check how that goes. So if I don't prefer a small angle and I increase my magnitude, then I will get this very high angle. But if I prefer a smaller angle and then I increase my magnitude, I will get this direct hit. Thanks for watching, and this should be the end of this series in this video.